Let's do this. Just kidding. It's kind of silly. All right, so if you look over my head, there is a bunch of stuff in our solar system. We've talked about some of it. Let's talk about the rest. And we're going to begin by going back in time and reviewing how our solar system formed. What you're watching right now is our solar system forming from a giant nebula, a cloud of gas and dust, where that is going to accrete into a star in the center, create an accretion disk. The star turns on, and that's what you see right there with those two jets. The solar wind starts pushing things out. You start to get planets accumulating and accreting, and all of the lighter material is swept up by those planets. The planets get bigger and bigger and bigger until you finally have the solar system that we see today. If you zoom out from this solar system, you're going to see that there is stuff here. One of the things that we're going to get to today, we're going to keep zooming out. This is not to scale. And it seems as though our solar system is encased almost like in a snowball, in a snow globe, if you will. And that snow globe is traveling through our galaxy, through the interstellar medium. So let's go over everything that we just saw. First, when the sun turned on, when this fusion first started, you saw those two jets coming out of the sun. A lot of people ask, what the heck is going on with that? Why did the sun have two jets? It doesn't have those now. Those two jets happen when stars turn on, and we have photographs of that happening. I wonder if you guys can see that happening in this photograph. Let's zoom in just a little bit. Do you guys see it now? Let's zoom in one more. And there it is. These are known as Herbig-Haro objects. Basically, when a new star is born, those jets happen because material is falling in to the star so fast. It's also got a magnetic field because it's so hot, it's ionized all of its gas. That material is then slingshotted out through the magnetic field of the little baby star. If the sun still had a whole bunch of material falling into it, it would still have those jets happening. The sun doesn't have that anymore, so those jets are not there. But it's basically the magnetic field slingshotting things out of it. If you want more of an explanation, there you go. The other thing that is formed during all of this are the things that you see on the screen. Moons are formed. Moons most likely were planetesimals that were caught by other planets. Our moon is weird. It's very big compared to our planet. That's why we think that the impact theory happened. And we can tell because of the density and the material that the moon's made out of. It's the same as Earth. However, the moons of the gas giant planets, we think were actually planetesimals that instead of smashing into the planets, they just got caught in that planet's gravity, and they've been orbiting ever since. The inner planets, other than the Earth, don't really have moons. Mars has two, but they're really tiny. They're basically little asteroids that just got too close to Mars, and Mars is like, I'm going to keep you guys. And they've been orbiting. So they're just asteroids that Mars kind of picked up along the way. Comets, asteroids, dwarf planets, all of those things are perfectly explained by material just accreting. They just didn't get big enough to be considered a planet. They just didn't get big enough to clear out their orbit. Material starts as little grains of dust, this, super small, just gets bigger and bigger and bigger, and then you have a bunch of asteroids, you have a bunch of meteors, you have a bunch of comets. All of these things are perfectly explained by the solar nebular theory of things just kind of slowly accreting and getting bigger, just like you're building a bunch of snowballs. The Kuiper Belt and the Oort cloud. Those are the two things that you saw at the end of the video, and we're going to get to those at the end of today. But first, I want to make sure that you know what the heck some of this other stuff is. Asteroid. Big chunk of rock in between Mars and Jupiter. That's all it is. If it's not in between Mars and Jupiter, it's not an asteroid. The asteroids are in the asteroid belt. So if you say that Earth is going to get hit by an asteroid, what you're saying is that Earth is going to get hit by a meteor, because a meteor is just floating through our solar system. Asteroids are very specifically in between Mars and Jupiter in the asteroid belt. Comets. Comets come from either the Kuiper Belt or the Oort cloud. Comets are basically big snowballs, and as they get closer to the sun, they start to melt. As they start to melt, they sublimate, and a bunch of that material then streams off behind it. So a comet is going to orbit a huge orbit, extremely long amounts of time. The close comets take decades. The faraway comets can take 10, 20, 50, 100,000 years to orbit just one time. Those are the ones that are called long period comets that come from the Oort cloud. The close by ones, those are called short period comets. They orbit in a shorter amount of time. They come from the Kuiper Belt. A meteoroid, any rock floating through space. Unless you're in between Mars and Jupiter, then you're an asteroid. If you're a rock floating between Jupiter and Saturn, you're a meteoroid. If you're a rock floating between Mercury and Venus, you're a meteoroid. Asteroids are only between Mars and Jupiter in the asteroid belt. Other than that, you are a meteoroid. Then what's a meteor and a meteorite? If a meteoroid gets close to Earth and enters our atmosphere, it's going to slow down because of the friction with our air. It's going to start to burn up. It's going to heat up very, very hot. It usually burns all the way up. That is what's known as a meteor. So a meteoroid is in space. A meteor is burning up in our atmosphere. And if it makes it through our atmosphere, smashes into the ground, that's a meteorite. So they're all the same object. It's just where they're located. Meteoroid in space. Meteor in our atmosphere burning up, shooting stars. Meteorite smashes into the ground. I actually have one of them right here. This one's iron. Some of them are made out of rock. Some of them are a mix of rock and iron. And if it wasn't 2020, when we had moon rocks, NASA also would have sent us a bunch of meteorites that you would have got to see and hold. But oh well. You're going to need to know the difference between these. One of the cool things about meteorites, meteoroids in general, is that they are chunks, usually of iron, chunks of metal that formed or that solidified in deep space. They solidified while they were just floating, which means that if you were to cut them open, they have this weird pattern that you only find in metal that solidified in space. You never find this in metal from Earth, only meteorites. And it's called the Widman-Stattern pattern, and you can see it on your screen. It's really cool looking. I'm not going to cut this meteorite open just because it would start to rust if I did. But this Widman-Stattern pattern only is found in things from space. Kind of cool. Asteroids, only between Mars and Jupiter. Some of them are round, some of them are big enough to be round. Ceres, the biggest, is. Most of them are not. Most of them are kind of weird shaped. So we have Eros, we have Ida. Ida is actually my favorite. Why is Ida my favorite? Because Ida actually has a moon. Ida has a little baby asteroid that is orbiting around it. So you have this little tiny asteroid and an even tinier little baby asteroid, and they are just orbiting around each other. I think that's adorable. Asteroids actually would have become a planet. So we have Mars, it condensed, formed a planet. We had Jupiter, condensed, formed a planet. In between those, there's a ton of material. Okay, there's not a ton. There is some material, and that material should have coalesced and formed a planet, albeit a small planet. The problem is that Jupiter was so big, its gravity kept pulling that planet apart. So the asteroids never had a chance to gravitationally attract to one another and form a little planet because Jupiter kept tearing it apart. Instead, they're a bunch of little rocks that are just kind of stuck in between Mars and Jupiter. It also means that the asteroids are basically what our solar system looked like before all the planets were formed. So this is the material that would have coalesced into planets. This is what the material that coalesced into Earth looked like before it became Earth, before it became Mars, before it became Jupiter or Saturn. Asteroids are some of the oldest things in our solar system. They're older than planet Earth. While there are trillions of asteroids in the asteroid belt, that's not a lot of material. If you were to add up every asteroid that exists in between Mars and Jupiter, it would make about 4% of our moon. So a very small planet. When you see pictures of the asteroid belt, this is what you get. You get a bunch of little pieces of rock, but it doesn't look like this. It doesn't look like that at all. Maybe you'll see a photo like this. You see a bunch of rock, floating around in space. Nope. Definitely doesn't look like this.
What are you doing? You're not actually going into an asteroid field.
They'd be crazy to follow us, wouldn't they?
You don't have to do this to impress me.
Sir, the possibility of successfully navigating an asteroid field is approximately 3,720 to 1.
Never tell me the odds.
Now, what does an asteroid field actually look like? This. It's empty. If you were in the asteroid belt, you would not see any asteroids. They are so far apart from each other. They're so spread out. They're so tiny. There's so little light. You wouldn't see any of them. If you had to drive a spaceship through the asteroid belt, you don't have to worry about running into one of them. You would just travel in a straight line and you would never even see an asteroid. There's so little material out there, and it's spread over such a huge amount of space, you can't even see the asteroids. It'd be similar to taking one single grain of sand and spreading it out over 25 square feet, or taking a single grain of sand and cutting it up into a trillion or so pieces and sprinkling it over an entire classroom. That's how spread out it is. The asteroid belt is almost all just empty space. When you see the asteroid belt, if you look above my head, you can see there's like little pieces going around in a circle. They only do that so that you can tell that it's there, that there are things there. In real life, you would never see any of them. All right, let's keep zooming out past the gas giants, out past Neptune, out to Pluto's orbit. And we get what's known as the Kuiper Belt. Now, I want you to think of the Kuiper Belt as a big belt that is surrounding our planets. It's on the same plane. It's on the plane of the ecliptic for the most part. And you have all of our planets. And the Kuiper Belt is like a big belt along the outside. This is not to scale by any stretch of the imagination. The objects would be so tiny you couldn't see them if this was to scale. They're just dots there so that to represent, that there's stuff there. The Kuiper Belt is mostly empty, just as empty as the asteroid belt. Estimates range from many orders of magnitude. All right, so if we wanted to estimate how empty the Kuiper Belt was, we're going to say that Earth is a single candy sprinkle. If we had been able to go out to the football field, Earth would have been represented by a candy sprinkle. And we're going to go on the big end of that estimate. Earth is a candy sprinkle, so we're going to put 30 candy sprinkles in our hand. Think of a cupcake has 30 candy sprinkles. Now you need to take those 30 candy sprinkles and cut them up into trillions of pieces. Trillions of pieces. And you need to spread those trillions of little tiny pieces all over 2 football fields. That is a lot of empty space. The Kuiper Belt is virtually all empty space. The things in the Kuiper Belt are so ridiculously spread out that you can't see them from one another. It's just empty. Most of space is empty. 30 candy sprinkles cut up into trillions of pieces spread over 2 football fields. Just so happens those are the 2 best football fields in existence, but I think you get the idea. So this Kuiper Belt photo is not to scale. What is the Kuiper Belt? Well, Pluto is its most famous inhabitant, and it starts just outside of the orbit of Neptune. Neptune orbits at about 30 AUs. And the Kuiper Belt goes from 30 AUs out to about 50 or 60 AUs. So if Neptune is at 30, let's go to the big end of that estimate. It basically doubles the size of our solar system. What is in the Kuiper Belt? Dwarf planets, little meteoroids, comets. There are hundreds of thousands of things bigger than 100 kilometers across. There's trillions of comets that are orbiting around the sun. It's named after Gerard Kuiper, who predicted that it would be there in 1950. Why did he predict it? Because he saw comets coming from way out in the solar system. And he calculated where their orbits took them. And he realized there had to be a repository, there had to be a place in our solar system that just had tons and tons of comets. When he died in the 50s, we did not have technology good enough to see anything out there. So he predicted it based on comets coming out of nowhere. He predicted that there would be a big, huge area of our solar system with tons of stuff in it. And it wasn't until the 60s that we had technology where we could actually see stuff out there. So taking data and making a prediction based on that data, that's science. That hypothesis was then proven to be true. So we found a bunch of stuff out in the Kuiper Belt. Some of them are bigger than Pluto. Pluto actually has a weird orbit. It's pretty elliptical. And Pluto actually, every once in a while, ducks inside of Neptune's orbit. Sometimes it's closer to the sun than Neptune. It crosses over Neptune's orbit, and immediately you might think, wait a minute, that means Neptune hasn't cleared its orbit of Pluto. That means Neptune's not a planet. Some people try to make that argument. The reason that it hasn't done that is because there's this weird thing with gravity and orbits. It's called being in a resonance. And that happens where Neptune is going to orbit 3 times and Pluto orbits twice. And it's kind of worked itself out so that always happens, and Neptune and Pluto will never be in the same spot when Pluto crosses the orbit. So there's no physical way for Neptune to clear its orbit of Pluto because of the way that the orbits have worked themselves out. There's a number of things out in the Kuiper Belt where Neptune's gravity is so strong that they've actually caused those things to become in resonance with Neptune. And all of those things are orbiting at a very specific speed so that they never really come near Neptune. All of those things are called Plutinos, named after Pluto. All right, so we've sent a single thing out to study the Kuiper Belt, and that was New Horizons. New Horizons flew by Pluto, got some great pictures, and since it's now past Pluto, it's traveling through the Kuiper Belt. We're like, why don't we see if we can see something else out there? And the next closest thing is called Ultima Thule, and it looks like this little tiny dot. This is taken from like out where Pluto is, not from Earth. This is all of the other stuff kind of darkened out so you can see just that object called Ultima Thule. This is how far away things are from each other in the Kuiper Belt. This is the best image of Ultima Thule that you can get from where Pluto is located. But just like Clyde Tombaugh found Pluto as a dot, and when we went there, we got much clearer pictures, we went to Ultima Thule. And we got there a few years ago. Started out as this dot here. Ultima Thule looks like this. Ultima Thule, you can tell it was 2 objects that smashed into each other and stuck together. If that's not more evidence for the solar nebular theory, I don't know what is. In fact, using the instruments on board, NASA was able to determine that Ultima Thule has a bunch of different densities, meaning that Ultima Thule is actually a conglomeration of dozens of little things that have all smashed together. This is direct evidence of things early in our solar system smashing together to get bigger and bigger and bigger. So these are all early building blocks of our solar system. Let's zoom out. We have the sun, we have the inner planets, we've got the asteroid belt, we've got the outer planets with weird Pluto orbit. We have the Kuiper Belt. We have Sedna. What the heck is Sedna doing? And all of a sudden, if you keep zooming out, like quite a ways, you get to this outer area, this glowing area. This glowing area is known as the Oort cloud. The Oort cloud is so far away that Voyager, who has technically passed into interstellar space, hasn't reached it yet. If we take a look at distances, Earth is 1 AU, and this is a logarithmic scale. Saturn is 10. Voyager is at about 100. The Oort cloud is between 1,000 and 100,000 AUs away. So 93 million miles is 1 AU. And this extends out to 100,000. 93 times 100,000 is a big number. It actually extends out halfway to the next closest star. So the Oort cloud extends out into interstellar space halfway to the next star. And this photograph makes it look as though there's a bunch of stuff out there. This is even more empty than the Kuiper Belt, which is even more empty than the asteroid belt. It's not the Oort belt, it's the Oort cloud. And the reason is that it is not a belt around the plane of the ecliptic, it's a cloud that completely surrounds the solar system in all directions. So how much stuff is out there? Well, let's go back to planet Earth being a candy sprinkle. And we estimate there's about the mass of 5 planet Earths. So take 5 candy sprinkles. Remember how big a candy sprinkle is. 5 candy sprinkles. And you are going to cut them into not millions or billions or trillions, not even quadrillions. You're going to cut them into quintillions of pieces, which is like millions of billions. So 5 candy sprinkles cut up into quintillions of pieces. And then if you remember, we had to, for the Kuiper Belt, spread that over, 2 football fields? Think of how spread out that's going to be. So for the Oort cloud, you have to spread it over 4 billion square miles. How much is 4 billion square miles? That's 20 planet Earths. How are you going to spread 5 candy sprinkles over 20 Earths? That's 1 sprinkle. You have to spread it over 4 Earths. There's not a lot of stuff out there. It's mostly empty space. But there are things out there. Yeah. Okay. Yeah. I teach this stuff, and my mind still can't understand it. If you remember, Gerard Kuiper hypothesized that the Kuiper Belt was there because he saw comets coming from there. And once our technology improved, then we could see stuff. We proved that hypothesis correct. Jan Oort, he has hypothesized that there is a Oort cloud out there. He didn't name it. It was named after him. Because we see these long period comets, these comets that can take 10, 20, 100,000 years to orbit just one time, we see them coming from every direction. These short period comets that Gerard Kuiper found all came from the plane of the ecliptic. The ones that Jan Oort was looking at were coming from up here and down here and over here and up here, and they're coming from all different directions, which tells us that it's not in the plane of the ecliptic. There's this giant shell of material, of icy comets, of little tiny things way far out. He calculated how far away these things had to begin their orbits. It's a long ways away. It is thousands and thousands and thousands and thousands of AUs away. Earth is 1 AU, and these comets are coming from tens of thousands of AUs away. These comets obviously don't make their own light, which means in order for us to see one of these objects, light from our sun would have to travel thousands of AUs away, bounce off something, and come back to planet Earth. And right now, our technology is not good enough to see any of that stuff. So we have never seen a single object in the Oort cloud. Not a single one. And I don't know if we're going to ever see a single object in the Oort cloud. We've seen objects from the Oort cloud. When they get close to the sun, we've never seen an object that is in the Oort cloud. So these long period comets that are taking thousands of years to orbit a single time, they come from the Oort cloud in all directions. We see them and calculate where they started from, and that's where we think the Oort cloud exists. We know there's stuff out there because we see the objects that have come from there, but we've never once seen a single object in the Oort cloud. New Horizons, the fastest thing that humans have ever launched in our history. It took 9 years to get to Pluto. It would take 500 years to get to the very inner edge of the Oort cloud. Needless to say, we're probably not going to get any up-close shots of Oort cloud objects anytime soon. I love when I go over an entire slide's worth of material before I show you that slide. Lots of comments are from out there. Jan Oort predicted it back around when Gerard Kuiper predicted the Kuiper belt. And we've never seen a single object in it. It's still a prediction. The Kuiper belt is a belt that goes around in the plane of the ecliptic. The Oort cloud is a shell that is completely enclosing. Enclosing is a bad word because it's so spread out, that is all the way around the solar system. These are not to scale, not even close, but they show you where the objects in these two regions of space are located. What I would like you guys to do now is answer these questions that you wrote down in your science journal a few days ago.